In this video, we're going to be taking a look at integer rules. Before we can go on to the integer rules, we have to know what an integer is. An integer is going to be a whole number and its opposite. If you have the number 1 and -1, those are both integers. The number -4, its opposite is going to be +4. Those are both integers. Now I could have 100, I could have -200, I could have 313, so on and so forth. Now you don't want to include decimals. Those are not part of integers. Now, when you look at certain algebraic terms, you're going to hear things like product, quotient, sum, difference. When you hear the word product, or when you see the word product, you're going to know to multiply. When you see the word quotient or hear the word quotient, it means to divide. Let's jump right into multiplication and division rules. Now, rule number 1, when the signs are the same for multiplying or dividing, okay, you simply do the operation and the answer will be positive. So if you have two negatives multiplying by each other, or you have two negatives dividing each other, because they are the same sign, you're going to get a positive answer. So if I had -3 times -3, okay, 3 times 3 is 9. Okay, now how do I know if it's positive or negative? If they both have the same sign, they will be, or your answer will be positive. You have a positive 9. Now, the inverse of multiplication is going to be division. So if you had, say, -4 divided by -4, that's going to give you a positive 1. The rule states if you have the same sign, okay, you will have a positive number. Now, on the flip side of this, if you had a +3 times +3, okay, if the rule is true, they're both positives, you will get a positive answer. Notice how your answer doesn't change. If you had +4 divided by +4, okay, they both have the same sign, they're both positive, you will get a positive 1. Now, that's rule number 1. Rule number 2 states that when the signs are different, okay, one is either positive, one is either negative, you simply do the operation and the answer will be negative. So if I had -4 times +7, okay, 7 times 4 is 28. Now, because one is negative and one is positive, it will always be negative. If I do the inverse, if I had the inverse of multiplication is division, so -50 divided by 2, I have a negative divided by a positive. Again, one of these numbers is negative, so my answer will be negative. Now, if I switch these, if I had -7 times +4, one of these values is negative and one is positive. Regardless, I'm going to get a -28. My answer does not change. Again, if you do the inverse, so now let's take +50 divided by -2. Okay, you have a positive divided by a negative. You will always get a negative value. Notice how our answer doesn't change. Just erase this. These rules do not change. Okay, the only thing that may change is the format. In this first example, you have -25 and then you have the division symbol instead of a fraction. They both mean the same thing. So -25 divided by -5, they're both positive values, or they're both negative values. The signs are the same. You will get a positive answer. Now, if you're looking at the bottom example, one of these values is negative and one is positive. So -4 times +8, because one of these are negative, you will always get a negative answer, -32. Now let's take a look at adding and subtracting integers. Now, if you are adding integers, notice that if they both have the same sign, okay, you're going to take the sum, or you're going to add both numbers, and you're going to keep that value. So if you had -6 plus -2, If they both have the same value, they're both negative, both have the same sign, -6 plus -2, you want to add them, right? Take the sum. So 6 and 2 is 8. Now, how do I know if it's negative or positive? If they both have the same sign, right, you want to keep that value. Think of money. Keep that sign. If you owe me $6 and then you owe me another $2, you will owe me in total $8. Now, if you had +7 plus +3, these are a little more straightforward. These are both positive values. So we know to add these, take the sum. Now, how do I know if it's positive or negative? If they're both positive, your final answer will be positive. Think of money. You made $7 and then you acquired another $3. In total, you have collected $10. Now, if for some reason the signs are different, you are not going to add anymore. You are simply subtracting both of these values. Now, after you have done that, you want to look at the value that is visibly larger. Okay? And that's going to dictate whether or not it's a positive or negative value. So let's look at the first example. -7 plus 4. One is negative, one is positive. The rule tells me if the signs are different to take the difference. So the difference of 7 and 4 is 3. Now, how do I know if it's positive or negative? Well, which number looks visibly larger, regardless if it's positive or negative? So I know the 7 is a bigger number, okay, regardless of its sign. So this is going to be a -3. Now again, if this confuses you, think about money. If you owed me $7, but then you paid me $4, you now only owe me $3. If I switch these, if I had a -3 plus a +6, these are both different signs. One is a negative and one is a positive. So take the difference. The difference of 3 and 6 is 3. Now, how do I know if it's positive or negative? The value that looks visibly larger. The 6, to me, looks larger. That is a positive value. This 3 is going to be positive. If you owed me $3, but then you made $6, okay, you now have on hand $3. Let's take a look at another rule. Now, what happens when we have to subtract two integers? Keep change is a rule that I've always followed, and I think it works better than most rules that are out there right now. Now, this is basically based on my own preference. If you have a different way of subtracting integers, go with whatever feels more comfortable and whatever is giving you more success. So if I am subtracting two integers, I'm going to take -7 and let's say -10. Keep change tells me to keep the first number, change the operation to the inverse, and change the sign of your last number. So if I'm keeping a -7, it stays -7. If I'm changing a subtraction sign, I'm going to change it to the inverse, which is addition. If I'm going to change this +10, this +10 becomes a -10. Now I'm left with an easier equation here, or an easier expression. -7 plus -10. Now we can go back to our addition rules. They both have the same sign, so we want to take the sum. We want to add them both. We will get 17 and keep the sign of whatever is going on. -17. It's a much easier problem to work with. Now let's try that again. Let's take -11 minus, we'll say 3. Okay? So keep change tells us to keep the first value, which is negative 11, change the subtraction to the inverse, which is addition, and change that positive 3 to the opposite, which is negative 3. Again, same sign, sum, negative 11 plus negative 3. Take the sum, which is going to give you 14. And if they're both the same sign, take that sign that we have, negative 14. Now, one example I want to look at, which is usually the hardest problem when dealing with math, is subtracting two integers. So let's take negative 9 minus, we'll say, a negative 5. Now, oftentimes you will see the second number, if it's subtracting a negative, you often see this in parentheses, just so that nobody's confused. So keep change tells us to keep the first value. Negative 9 stays a negative 9. Subtraction sign turns into a positive, which is the inverse, and a negative 5 becomes a positive 5. Now, I'm left with negative 9 plus 5. Remember, the signs are different, so go back to your addition rules. When the signs are different, you're really taking the difference. So 9 minus 5 is 4. And keep the sign of the larger number. What's visibly larger, the 9 or the 5? Well, it's the 9, so it's going to be a negative 4. You can say to yourself, if you owe me $9, but then you paid me 5, you now owe me $4. Let's try one more for practice. Negative 10 minus negative 2. So keep change tells us to keep the first value, which is negative 10. Change subtraction to addition. And take the last value. If it's a negative 2, we're going to take the opposite of that, which is positive 2. Again, we have a negative plus a positive. When the signs are different, take the difference. The difference of 10 and 2 is going to be 8. Now, how do I know if it's positive or negative? Well, whichever is visibly larger. The 10 is visibly larger, so this is going to be a negative 8. If you owed me $10, but then you paid me 2, you still owe me $8. If you owed me 10, you gave me 2, you still owe me $8.